Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for finding the product of an array except self problem. Let's look at the problem description. We are given an integer array nums and we have to return an answer array such that the answer of I is equal to the product of all the elements except that number. And the product of any prefix or suffix of nums is guaranteed to be fit in 32-bit integer. And we have to come up with an algorithm with order of n time complexity and without using a division operation. Okay, let's take a look at the example 1. So we have the nums array 1 2 3 4. The index 0 of the output array should have the product of these three numbers, 2 times 3 times 4, 24, and the index 2 product of 1 2 and 4, 8, index 4 3 1 times 2 times 3, 6. The constraints are the length of an array is ranging from 2 to 100,000 and the values are ranging from -30 to 30, and the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. Space for output array is not accounted as an extra space. Let's look at the approach to solve this problem. For this input, the expected output is 24, 12, 8 and 6. The first approach is the brute force approach. In this, we will traverse the array n times. On ith iteration, find the product of all the numbers in the array excluding the num I. So basically in the inner loop, we keep multiplying and ignore the number when both the outer loop index and the inner loop index are same. And we keep multiplying the rest of the elements, and finally we assign that product to the result array. So this approach, the time complexity is order of n square. And the second approach is a two-pass approach. So in this case, we traverse the array two times. The first time we traverse from left to right. Second time we traverse from right to left. Okay. So and also we maintain two variables, prefix and suffix. So when we traverse left to right, first we assign the prefix value to the result arrays index I, and we keep multiplying the prefix with the input arrays num of I and keep updating the prefix. Once that traversal is done, then we start from right to left, last element to the first element. So in this case, in each iteration, we keep multiplying the product of I with the suffix so far we computed. So initially that is set to 1. As we traverse the array, so on the iteration 3, the suffix is 1, and here it will be 4, here it will be 12, here it will be 24. Okay. So finally we get the expected output in this approach, and here we have to traverse the array two times, order of 2 times n. We remove the constant factor out, and so the time complexity will be in this case order of n. Let's look at the flowchart. Input for this procedure is nums array, and first we initialize the count variable and prefix and suffix variables. So prefix and suffix will be initialized to 1 and the count will be initialized to the length of the input array. Okay, and then we allocate the space for the output, so that will be equal to the size of an input array. Okay, so this one the first traversal, so we start from left to right, so the index is initialized to 0 and we check whether we processed all the elements. If not, we assign the current prefix value to the product of IDX, and then we multiply the current prefix value with the value pointed by the IDX in the input array and assign it back to the prefix, and then we increment the IDX. We repeat this until we process all the elements. Once that is done, we come out of the loop. Then in the second traversal, so in the second traversal we start from the end of the array. Okay, so initialize the IDX to count -1 and we check whether we processed all the elements. If not, we updated the product of idx by multiplying that product of idx with the current suffix value, and then we updated the suffix value by multiplying that with the value pointed by the idx in the nums array, and then we decrement the idx so that the next element on the left will be processed. So we repeat this until all the elements are processed. So once we come out of the loop, we have the product output array. Let's move on to coding. First I initialize the count variable with the length of the input array. Then I allocate space for the product array. Then I initialize the prefix value to 1 with 1. Then the first traversal starting from the index 0 all the way to the count -1. So in this, in each iteration, I assign the current prefix value with the in the product of I, and then I updated the prefix by multiplying the current value with. Then I initialize the suffix variable with value 1, and then I write the for loop for the second traversal starting from the end of the array. So in each iteration here, I updated the product of I by multiplying the current value with the suffix, and then I updated the suffix value by multiplying the current value in the input nums array. Finally, I return the product array which contains the expected output. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. We have the input array that has 3 elements 2, 3, 4. So the expected output will be first index of the product array will be the 3 times 4 12, and the second one will be 2 times 4 8, third one will be 2 times 3 6. Okay, so let's do the code walkthrough for this input. So first we initialize the count to the size of the input array, which is 3, and then we allocate space for the product array, which will be the output. Then we initialize the prefix variable to the value 1. We start traverse from left to right, index starting from 0, and so when we enter the loop, the prefix value is 1 and the index value is 0, so we are pointing at the index 2. So when we leave, the prefix value will be assigned to the product of index 0. So that's what we are seeing here. And then the prefix value is multiplied by the current value pointed by idx, which is 2. So 2 times 1, 2. So when we are leaving that iteration 0, we have the prefix 2. And in the iteration 1, when we enter, the prefix is 1 and the index is pointing to 3. And now we are assigning the current prefix value at the product of index, which is we are assigning 2 here. Okay, and then we multiply the current prefix value with the value pointed by the idx. So 2 times 3 6. So when we leave that iteration 1, the prefix will be 6. On the last iteration, the prefix is 6 when we enter, and the index is pointing to the last element of the input array, and we assign this prefix value in that index, which will be 6, and then the prefix will be multiplied by the current value, which is 4. 4 times 6, 24. So the first traversal is done. So now the product array has 1, 2, 6. Next we do the traversal from the last element to the first element. So the index is initialized with count -1 and it goes all the way to 0. Okay. So and then the suffix is initialized to 1. So now when we leave this iteration, at that time the product of I will be the current value of product of 2 multiplied by the suffix will be assigned here. So it will be 6, and the suffix value will be multiplied by 1 times 4. So it becomes 4. Suffix will be multiplied by 4. Then when we leave, the suffix will be 4, and the product of 2 will be set to 6. Now when we enter the loop, the suffix is 4 and the index is pointing to the value 3, and when we leave, we updated the product of 1 with the current value of product of 1, 2 times 4, which will become 8. Okay, and then the suffix 3 will be multiplied by the value pointed by the idx1 in the input array now. So 4 times 3, 12. So when we enter the last iteration, the suffix value is 12 and the index is pointing to the first element, which has the value 2, and now we assign that product of 0 with the current value of 1 times 12. So it will become 12, and the suffix will be multiplied by the current value of 2, and then which will become 24. So finally we have the product our arrays has 12, 8, 6. That is the expected output, 12, 8, 6. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. So this input array has 3 elements. So how many times this for loop runs and this one runs? So if you look at it, this will run as many times as the number of elements in the input array. This is also the same. So 3 times plus 3 times, totally 6 times, and which is order of 2 times n. So we can remove the constant out of it. The time complexity of this solution is order of n. And with respect to the space complexity, it is order of 1 because we are not allocating any additional space for intermediate processing. So we allocate space only for output and we use few variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.